Hey, last example from lesson 4 on log differentiation. Then after this example, we're gonna jump into probably like the 2018 exam and just look at a couple more things just to kind of help us do some review here. So this question, y equals x to the x squared plus 5. A lot of us get kind of messed up on this question. We want to treat it like a polynomial function, x cubed plus 3x squared plus 4. But this is not polynomial. Polynomials have x for the base, but they have numbers for the exponents. So that's not what you have here. You got x for the base, you got x squared for exponents. You got variable. Some of us try and treat this like it's an exponential function because we got an exponent, x squared plus 5. That's an exponent. But an exponential function has a base that's a number and an exponent that's a variable. So this is variable. So it has to be treated differently. It's not polynomial. It's not exponential. And if you graph this thing, it's kind of a neat looking little function. So anyways, when you get a question like this is probably the only question that you truly have to use what we call log differentiation with. The other questions, you could fight your way through and use all kinds of rules. But when you've got this variable thing happening or function thing happening, you got to use log differentiation. So again, log of y, right? So you just log of y. X squared plus 5 is the exponent, so it's x squared plus 5 times by the natural log of x. So now you've turned this into a product. You've got a function times by a function. My first function is x squared plus 5. My second function is the natural log of x. And we've done lots of polynomials, so we know x squared plus 5, the slope is 2x. We've done lots of logarithms now. Log differentiation, great stuff. We know the derivative is 1 over the function times by the derivative of the function. So in this case, it's 1 over x times by the derivative of x. So it's just 1 over x. So we put this into the product rule. F prime g, 2x times natural log of x, and f g prime x squared plus 5 times 1 over x, right? We can see here now we're going to probably end up doing some nice mathematical simplification, and we're going to put the y back in as well. So like we showed on our previous examples, when you have the y value, when you put things back in for cross multiplying, this y becomes x times x squared plus 5. How do you clean this up? Well, common factoring is you take out the lowest exponent, right? Take out the -1. There's nothing common for numbers. This is a 2, this is a 1, so nothing for numbers. Just factor out the 1 over x. So when you factor out a 1 over x from 2x becomes 2x squared. This natural log of x doesn't factor out. This x squared plus 5 doesn't factor out. You're factoring from the 1 over x and you're factoring from the 2x, right? So then, like we did back in math 10, like you did back in math 20, your bases are the same. You have x base and you have an x base. Here you're dividing. So what do you do when you divide? You subtract exponents. This has an exponent of 1. This is x squared plus 5. So x squared plus 5 minus 1 is x squared plus 4. So your answer, what does the slope look like? The slope looks like x times x squared plus 4 times by whatever this cleans up to, and it doesn't clean up at all this time, 2x squared natural log of x plus x squared plus 5. That is a mess. All right, sometimes these things clean up way nicer than that. All right, so that's the last example. I've got a document open here, and this is the from our website, right? So if you go to the website, Trig and Logs 2018, it'd be a great place for you to review. Of course, if you have to do some more logs, some more limits, that kind of stuff later on. What I want to show you though is if you ever have an exam and we put trig and exponents logs together, so we will layer the questions. All right, so you got your basic trig definitions, secant, x squared, tangent 2x. Here you got a layer. You got an exponential function tied into a trig. So don't let that scare you, right? Because you know the rule when your base is 3 sine squared of x. We know the rule is repeat the function. What's the stretch factor? And then derivative of the exponent. So repeat the function. What's the stretch factor? Natural log of 3. What's the derivative of sine of x squared? Well, sine of x and then squared is the chain rule, right? So this 2 is this 2, right? And then the sine x becomes degree 1. So sine went from sine squared to sine degree 1. What's the derivative of the sine ratio? It's the cosine ratio. And then the way this cleans up is you see 2 sine x cos x. That's an identity of sine 2x. So that's a neat question in terms of layers, right? When you combine exponential functions and trig functions. Then later on down here in question like number 5, we're going to do some more differentiating. This looks like kind of a messy question, 1 over the x root of 10. You just remember, if you had 1 over the square root of 10, square root of 10 is 10 to the half. So 1 over root of 10 would be 10 to the negative 1/2. So in this case, your index is x, so it's 10 to the negative 1 over x. And that just means then that, again, this x now is in the bottom of a fraction. So this minus 1 is the minus sign, this x to the minus 1. So we want to change a question that has an index in it to be an exponential function. Base is 10. Exponential function is negative x to the negative 1. So what are the rules? The function repeats, right? So whatever you have for the function repeats. Looks like a mess, 10, negative x to negative 1. Well, that just becomes root, the x root of 10 again, how it started. And then what's your stretch factor? Your base was 10, your base was 10. So what's the stretch factor? Natural log of 10. So there's your stretch factor. And then what is derivative of this expression? So this negative 1 times by that negative becomes positive. This decreases by a degree, becomes x to the negative 2. So what started off looking like a fairly nice question actually ends up being a pretty nice question as well. It's just that there's some mess in the middle. Hey, and here's like the last example we did. This one's just not as complicated. It's a function to a function. So we need to differentiate this. So without being told, we need to remember to take the log of both sides. All right, so when you have 2x cubed, it's the value that goes in front of the log expression. This is a product rule. So this would be derivative of 2x cubed is 6x squared times by the natural log of x. And then your f is 2x cubed times by the derivative of natural log of x, which is 1 over x. Clean things up. 6x squared natural log of x times 2x squared. So this is really 2x squared. There's a 2x squared here. That's why we factored 2x squared out. If you take 6x squared divided by 2x squared, it's just 3. If you take 2x squared and divide it by itself, it is 1. I've got a base of x, a base of x. So I'm going to add my exponents. So this 2x cubed adds with this 2. So 2x cubed plus 2, and there's your 2 stretch factor. All right, so anyways, just again, there's lots of questions to look at, lots of ways to kind of go back and review, trig, review exponents and logs. But we are done, right? We are done in the last lesson here. So hope you had some fun with these questions. Love these questions, love the layers. All right, we'll be in touch. We got some more work to do yet, so take care.